All right, let's get into solving rational equations. That's from section 7.6. We are just going to go through some examples that will teach us how to do this. By doing that, we're going to be able to match these objectives. First, we're going to talk about the difference between the expressions and the equations, which is very straightforward. I'm going to give you guys one example each of solving using numerical methods and graphical methods, which is applicable for any type of equation. And then we're going to use algebraic methods to solve them. All right, here I have four different either expressions or equations written out for you to just look at for a second and tell yourself which ones are expressions, which ones are equations. Now, the reason that this is something that I am actually focusing on is because, first of all, it's an objective from this section that I think is important for us to talk about very briefly. But also, I can see why this might be something that people have trouble with. You have a bunch of different fractions and terms, and sometimes you don't see when there's an equal sign, and sometimes you think that there is one. And so you just have to look at the, basically the conjunction that's here, and you determine if there are any equal signs. The fractions make it look a little bit more confusing. That's why it's something that we actually note. We actually talk about this. Okay, I'm gonna pause real quick. I'm gonna pause so that way you guys can write down which is which, and then very quickly we'll talk about it. All right, if you got these for your determination, then you've got an idea of which is which. Very straightforward. That's all there is to this part. I'm going to erase this and move on. All right, so our next objective is to talk about finding graphical solutions for rational equations. So what I have here is the equation that we need to solve. 1 over x equals 4x. It's pretty straightforward. It's a small equation to consider, but basically what you see is you have your left-hand side equation, or a function, 1 over x, and your right-hand side function, 4x, okay, and I have graphed both of those two functions separately. By the way, I use Desmos, very easy, very quick, and you can see the two equations in the same positions basically on the coordinate plane, but I don't have them overlapping because I want to talk about what that means when we overlap the two functions basically. And if you'll notice in the equation that I have right here, I have highlighted the left hand side of the equation. I'm going to write down, this is the left hand side, LHS, and this is our right hand side. I've got both of those things graphed, and what I'm trying to do for any equation, for any function, or sorry, for any time you're trying to solve, you're setting the left-hand side equal to the right-hand side. You are setting that function on the left hand equal to the function on the right hand. So when we're talking about this graphically, we're saying that we want to find, oh, my hand just hit a button, I'm sorry. There we go, sorry. We are trying to find where these two functions are equal, where they overlap, okay? So where does this curve, the yellow graph, or the yellow function, intersect with the green function? So where are they equal? Let's see. I want to find that out. That's what I'm doing when I'm solving an equation, and that's what I'm going to do graphically in just a second. Let me get that graph ready. Alright, so here I have the two functions now graphed on the same coordinate plane so that you can find and see that intersection point. And so if you look, there are 2 points, there we go, where they intersect. And whichever calculator you use, you'll have different methods to finding those 2 points. When I use Desmos, it's very straightforward. It's like you just kind of click the points and it'll show you, but you can also see the table. Hold on. I can't tell if I paused my video or not, so hopefully there's not just a big empty chunk of time in there. Anyway, so I have found these two coordinates as 1/2, 2, and -1/2 comma -2. So the good thing is that we were only trying to find the x value, so we don't actually need to worry about the 2 and the -2. Those are y values. That has to do more with the function itself. But we were trying to solve for the x, okay? So an easy way to check this also is if you plug in the numbers and see how it fits. So if I plug in -1/2, I'm sorry, no, that's not an equal sign. So if I plug in -1/2, then I'm going to get, let me pause it so that you don't have to watch me write everything. What looks like this here, and then I need to simplify it by just basically multiplying by the reciprocal on the left-hand side, and on the right-hand side, just carrying out that calculation. When I do this, you'll see that the two sides, the left hand and the right hand, give me the same value. That means that this is a true solution. It's actually a solution for this, so it works. Okay, let me just very quickly do the same thing for 1/2. You can pause the video here and just take a look and just see that that does work. So we have a very straightforward way of graphically solving the functions. All you have to make sure that you're doing is getting the entire function, or like the entire important part of the shape, in the graph so that you can actually see this. So if I had only looked at the graph from here, then I would be missing out on one of the solutions. Just make sure that that's not something that you're doing, and you should be fine. Let's move on to numerical versions of this. All right, so next we're going to talk about finding numerical solutions. I've got a new equation for us. The left-hand side is x over 3, and the right-hand side is 2 minus 2/3 x. So the same idea holds for numerical solutions as it does for graphical. And again, this works for any equation. You can look at it like this always. The problem with numerical solutions, well, actually the problem with both, is that when you have decimal answers, sometimes you just can't get it on the graph, and you just can't get it in a table without being way too specific. And that's why we move on to the algebra in a little bit. But either way, here we have this left-hand side is x over 3, and the right-hand side is 2 minus 2/3 x. So what you have to do is you have to say, I want to know as many numbers as possible for both of these functions, and I want to see where they both have the same y value. So let's make I'm going to start making a table. Let me get that drawn out. Okay, so I'm tempted to show you the graph just so that you can see what I did here, but I want you to just think about this in terms of the table, so we're going to stay away from that for now. I went to just a graphing calculator, and I typed in the left-hand side of the equation as one function, and then I typed in the right-hand side of the equation as another function, and then I just went to the table and got these points. Okay, now on a graphing calculator, you're going to get decimals, but the general idea will still hold, okay? But I don't like decimals, especially not repeating decimals like these functions are, so I converted them into fractions and wrote them all down for you so that you can see. So if I'm looking at these values here, I'm going to take a glance through each x value and what y values that gives me. So when x is -5, I get a -5/3 for this y value, and then a 16/3 for this y value. And that's what I'm going to do. I'm going to compare, I'm going to look through all of them. So these are different, 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 and these ones here are not different. Notice that these are the same. I know I'm writing in highlighter, but it's just quicker. So that means that at this x value, so I'm going to write this down real quick. I'll write it down before I read it out loud to you guys, or I say it out loud. Okay, so at this x value, our functions have equal y value, or just basically our functions are equal. So this tells us that our solution, or x equals 2. Because that's where this happens. That's how you numerically solve a function. if I gave you a test full of equations that you did not know how to solve in any other way, you should still always be able to give me an answer by using either graphical or numerical solutions. And if you can't, either I gave you some really ugly numbers and that was mean of me, or you should be able to solve it using an algebraic method, or maybe there's no solution, which we're not going to get to right now. But either way, this is a fallback method if you are struggling with functions and solving. You should always be able to get at least a general idea of where they're equal, okay? All right, we're moving on to solving rational equations algebraically. So we're going to do an easy one first. This one is y over 6 equals 5y over 3. Some of you may be able to look at this equation and solve it in your head, but we're not going to try doing that. We're going to start by doing that method that we've done since we were in like 5th grade, or when we first started learning pre-algebra, solving the easiest equations that aren't just this one step, is solving a proportion. That's what we have here. And the easy way to do this, the way that I like to write it out, is what I've been doing since I taught 5th graders, which is I draw a little butterfly. Got your wings, you got your little antenna, you're cross multiplying, okay? And I'd like to note, for anyone who might wonder why you cross multiply, why you're doing this, you're just putting a lot of different steps in, or a few different steps all together as one, okay? So when you cross multiply, you're going to end up with an equation that no longer has those fractions. So when I cross multiply, I'm putting together the things that are in each circle, okay? So, oval. So I've got the y and the 3, those get multiplied, and 6 times 5y gets multiplied. That's what's happening in this line here. And you get 3y equals 30y. Might look a little confusing, not confusing. Sorry, a little bit of a brain fart there. Anyway. Alright, so no matter what, the next thing I did was the basic inverse operations. I want to move my variables together so that way I can just solve I can isolate it and solve. So now that I've gotten my y's on one side, I'm just going to divide both sides. And I get that y equals 0. So very, very easy problem. And no matter whether or not your numbers work out like this, the method stays the same. When you have two fractions equal to each other that are just like this, nice and easy, then you can do this. So let me write out an example where you cannot cross multiply. Alright, so this example that I have here where you can't cross multiply, I hope you can see why this is the case. We have on the right hand side an extra operation. We don't just have the division bar, we've got an addition that is bigger than that. We have two fractions being added. You can't cross multiply like that because when I go to do my little butterfly, I can't just do that. That doesn't work. That x and that 3 aren't together. So if you think that you always want to cross multiply, then you have to get those two fractions, you have to do that addition first. Then you can cross multiply. Then that's not always going to be the easiest method. Alright, so this next equation with a low medium level difficulty in that, and I have already written down why it's harder than the last one. First of all, you should note, when you're looking at this, on the left hand side, you have what I just talked about, where you have two different terms. You can't do cross multiplying like this. And then when you're looking at it, you're like, well, I can't just put them together yet because my denominators on the left hand side are different from each other. So let's do this the easier way first, and make the denominators the same so that way we can then do the cross multiplying. And then we're going to do the harder way, not harder. We're going to do it the way that will make it, that's going to have a connection to the harder problems, okay? So just a second. Okay, so if you'll see here, I have done some converting. You had a 1 that's really easy to turn into a fraction with whatever denominator you want. So I did that with that middle line in the red coloring, And then when you look at my last line, now they both have the same denominator. I can just combine those together. And in doing so, I have one fraction on each side. So we can go from there. And then we can cross multiply. From here, you should be able to solve this yourself. However, I am going to make a note of something. Well, hang on. Sorry, I'm going to write down that you can cross multiply. Alright, so I've got that in, but I want you guys to notice something very specific about this problem. This isn't always going to happen. But that denominator of x squared minus 1, I'm going to rewrite it using some factoring that we should know by now. We should recognize that you can actually factor that denominator using the difference of perfect squares, or the general factoring methods. It'll still work. But either way, when you do this, you should notice that your denominator here on the right hand side actually has all of the left hand side in it. So we can actually use this for this specific problem. We can do it a little easier. I'm going to multiply both sides, or not both sides. I want to multiply my left hand side with an x plus 1, and suddenly my denominators are the same. But of course I can't do that to just the bottom. I have to do it to the top because because I tossed that in. I can't just toss random stuff in. So now my denominators are the same. So let's look at what that does. The great thing is, when you have that, when the denominators end up the same, then you actually don't even need to worry about the denominators anymore. They basically just cancel out. So, and for anyone who might need a little more explanation of that, so let's say I'm just trying to move things around. I want to get things to get out of the denominator. So I'm going to multiply both sides by x plus 1. And that cancels the denominator there out. So times x plus 1. And when I do that, that denominator cancels out. And then I'm going to multiply both sides by x minus 1, because that's in the denominator. So that cancels out that denominator now, and it does the same thing on the other side. They cancel out from each other, and you end up with just the numerator. And I'm going to admit, that's not an easy equation immediately to solve off the top of your head. You're going to have to use factoring or quadratic formula, things that we haven't really talked too much about. But no matter what, that is an easier equation than solving this cross multiplication problem. I don't want to solve that cross multiplication. That doesn't look very nice. So that was a problem-specific way to cut down on your work. But it's not always going to work that way exactly. But that's a lead-in to the next type of problem we might have to do. By the way, the solution to this, if you want to solve it and find your answer, which I highly recommend. We always want to check and practice and do our extra math whenever we can. Anyway, when you're solving this, you should get x equals -3 and x equals +1. Alright, so our next one, our more challenging sorry, I forgot to highlight this. Our more challenging problem here is this one you see below, 2 over x plus 3 minus 1 over x minus 3 equals 1 over x squared minus 9. So, you should notice that, again, you have two fractions on the left-hand side. And don't worry about it being on the left-hand side specifically, just that you have two fractions on one side. And all three denominators are different. This isn't like the last one where we could turn that second denominator into anything because it was just a 1 value. Now we have to consider all three of them. First thing I do, by the way, I haven't mentioned this, is put parentheses there. And the second thing I want to do is I want to try and make my denominators the same. But that's going to take a little bit of work. That's not as easy as just multiplying. So let me think about what's even in my denominators. If you look, you can notice, or you should be able to notice, you should be comfortable with the idea that x squared minus 9, that might have some extra stuff in it. So I'm going to factor that real quick. You'll see my factorization in the second line here. When I do this, you should note something really important. The denominator in one fraction on the left-hand side matches the right-hand side denominator, and the same for the other. Okay, so we now have a lot more similarities here. This problem gets a lot easier because of this. So I can probably get my denominators together here, okay, by using what I consider, I call it a trick, okay, and I don't want you to overthink this. Basically, it's me condensing more than one step into this work here. So I'm going to multiply this numerator by x minus 3, and I'm going to multiply the second numerator by x plus 3, and then my new denominator will have x minus 3 times x plus 3. It doesn't matter that the order changed, I'm just writing them down underneath each other. So that's what my new denominator will look like, okay? So let me rewrite this all together. Let me pause it. I'm trying to pause it that way I'm not wasting your time with you watching me write stuff, by the way. Alright, so I have my new setup here where now, again, I've gotten my fraction on the left-hand side equal to my fraction, I'm sorry, I've gotten both the left-hand and right-hand side down to one fraction, okay? So, and I did this by this little trick where I basically made the denominators the same. And now that my denominators on both sides match, what we saw in the last problem is that we can cancel out those denominators. Oh, that 3 is weird, sorry. And we have the same numerator in, I'm sorry, we just have to deal with the numerators. And from here, it's a pretty straightforward equation to solve. I'm going to do that off screen, basically. Alright, so out of all this very complicated equation, we have that x equals 10. I'm going to very briefly draw the graph for you guys to discuss something here, something very important that I haven't talked about yet. Alright, please excuse the messiness of this graph. It's kind of crazy, but it's the two functions, okay? And they're in different colors. The red one is one separate function, and well, basically it's the left-hand side, and the blue one is the right-hand side. Actually, it might be vice versa. Yeah, no. The red is the left-hand side, okay? And the blue is the right-hand side. But basically, I only have one point where these intersect, despite how complicated they are. At x equals 10 is where they intersect with each other, okay? But you've got a lot of other stuff going on that we haven't talked about. And I want you guys to consider where, and we've talked about this briefly in class, but not in this video. I want you to consider where this really funky stuff happens, okay? Remember that we talked about this and we described it as basically time travel. I'm moving in one direction away from my house, I'm moving away from my house, and then suddenly I have teleported across town to the opposite side of my house, and I'm moving around again. We can't teleport. We can't just change position like that. This graph has these teleportation points, the points where it does not work. It is impossible, okay? And those are points where we have not no solution, where the function essentially doesn't exist, okay? And that is at x equals -3 and x equals 3. And we've talked about why those values are it. I don't have time to go, I know the video is getting kind of long. I don't have time to go into all of the math behind it, but if you'll notice, okay, what we've got here is we have those impossible points where it equals 0 in the denominator, okay? Where it equals 0 in the denominator. If I plug those values in, I'm going to get zeros down there. That is where all the rules break. That's where it's not allowed. That is what you guys need to be looking out for. So our solution is at x equals 10, and the function does not exist, or it's undefined at those other points, okay? So I want you, if you're not asked for these values, that's fine, but I just really want to stress that those things those values are stuff that you need to be looking for, okay? We're going to move on. Alright, so the last type of problem that I want to talk to you guys about in this video is solving rationals using the LCD. it's not actually different from the other problems that we've used, but this example here gives a better idea. This is not a harder method. This is just a method that applies to more problems where things don't cancel out as nicely as they have in what we've looked at. So you've got this problem where all three denominators are different and they don't cancel each other out. So what we're going to do is we're going to say we can multiply everything by stuff that will cancel out all the denominators, okay? And that would be the LCD. All right, so I've got what I said just now in better terms, written in red, and now I'm asking myself, what is the LCD here, okay? So in very, very, very basic terms, explanation, you want to write out all of the different terms you have and cancel out anything extra. So when I look at this, I have x minus 1 is one denominator, x is another, and 9x is another. If I'm looking at all three of these terms, I can see that both the second and third have an x. I don't need that twice. So I'm just going to take out one of them because that way I have all the items represented at least once. Sorry, my mouse isn't hitting the pause button. Alright, so my LCD is 9x times x minus 1. That's the common denominator that will not have anything extra. That way I can cancel out everything without having to do more work for myself. If I didn't cancel out that x, or if I didn't take out one of those x's, it will still work. You could just multiply the whole equation by all three denominators, and that way everything will cancel out eventually. It just makes yourself a little bit more work later because you have a little bit more that you got to take out. So let me show you what that would look like then. Not the, sorry, where's my mouse? Not the multiplying by everything, but multiplying by the LCD. All right, so I have this here, so that way everything is written out. Some students I've seen over the years will write things down with a little bit less, they'll just skip what is already there in the denominator. I don't recommend that. Do it like this. It's just a little bit more writing, but you're very, very clear here. All right, you'll notice I have canceled out what is shared in the denominator and the numerator. So now you should see I don't have any denominator again. We've managed to wipe this equation down to a simple, I say simple, but a basic equation like we've seen for a long time in algebra. All right, you can see from my work here, I'm sorry, I say I'll write every time I restart the video, sorry. Anyway, you can see from my work here that you can solve this down to one value. In this case, it's x equals 10. And I recommend very, very much that you take that answer back, and I've been doing it in my head for all of the problems that we've worked on here, and just plug it back in, at least in your head, so you get 1 over 10 minus 1, 1 over 9, minus 1 over 10. Okay, so it's a little fraction problem there. Equals 1 over 90. That's 10 over 90 minus 9 over 90. That gives you 1 over 90. Okay, so that works out. You don't have to do it in your head. You don't have to do it by hand. You can do it in a calculator. But if you're not checking your answer, you might get something like we talked about here. If one of my answers ended up being a -3 in this problem, then that answer is actually not a solution. It doesn't work. So you've got to make sure that you are getting proper solutions, not extra ones or extraneous solutions. Okay, so that would be basically the bulk of solving these types of problems. All the different example methods that I can give you. I didn't mean to, but I did lie accidentally earlier, and I said that we were on the last type of problem that I wanted you to see. I do want to show you one more thing, and it's just solving for variables. So you'll see what I have here. Solving an equation for a variable. I wasn't exactly clear when I said solving for a variable. We do that all the time, but it's solving basically a formula. So when you have more than one variable, you're solving so in this case, you're solving for b in terms of the other variables, in terms of A and T. So let's work on that. Let's get through this one, and then we should be done. So let's try and isolate B. That's your goal. Sorry, my chair is creaky. When I look at this equation, when I look at that first line, I have a moment, every time I see a problem like this, a moment where I'm stumped because I'm asking myself, how am I going to get B out of the denominator and when it's already in the numerator? So I ask myself, how can I move it out? Okay, and then that's when I do what you see in line 2. I say, well, let me just multiply both sides by that value, okay? Because once I multiply that, those pieces will cancel out. And now B is not in a denominator. You want any variable you're solving for, you need to get it out of any denominator whenever possible. And that's not a hard and fast rule from the very beginning, but it does make a big difference to do that right away when possible. So from here, then I see that B inside the parentheses. That's my next problem. The next issue that I need to eliminate. From here, you'll see what I've done to get that B out of the parentheses. I've eliminated the parentheses. What you have to do is you have to multiply or distribute that T to both the A and to the B. So that's what the next line looks like. So when I've done this and you're looking at the equation, you should notice that now I can get both of my B terms on the same side of the equation. If you look, I've rewritten that line, that third line on the screen, so that way you can see in the fourth line how I get the B terms together. It's just basically an inverse operation. And then, so from here, I see that both of those terms on my right hand side have a B in them. So I just need to get that B out of those two terms. The method I use to do this is factoring the B out. If I factor that out, suddenly I've got one B in the entire equation, and I can see right away how I can get that B isolated, what operation I can do. You can see in my work here that I've done that. I have isolated B by dividing both sides by A minus T. All of that was one factor that I can get away from B. And I've solved this formula, or this equation, for the variable B. So now I have expressed B in terms of A and T. The reason I'm saying that is because that comes up as a problem on a lot of tests for this type of content, to express one variable in terms of another, and that's how you do this. It's just you have your equation for that variable using those other variables, okay? So express B in terms of A and T. That is the last problem from this section. I tried to keep this as short as possible. I know it's still 30 minutes long, but hopefully you should have a very clear idea of how to do all of this. Definitely look at more examples. Find more things to explore with this. I'll be honest, I looked at the application problems from this section, the word problems basically, and I was stumped by the way that they were wording it and how I had to set up the problems, because I'm not used to looking at them like that. I'm definitely going to go and do some of those problems for practice and make sure that I am, totally on board with, or not on board, totally clear about how it all works. You are not the only ones that ever have trouble with this. Even people who have been doing these types of problems for years see new problems and still struggle sometimes. It's totally the norm. You can do this. Once I can get my mouse to the stop button, then I'm going to end this video, and I will talk to you guys later.